Google just released DiffusionGemma, open source, Apache 2.0 license, and it generates 256 tokens in parallel instead of one at a time. This matters because every production language model you interact with, Claude, GPT-4, Llama, generates one token per step. Chain them together, you get latency. Diffusion-based generation flips the architecture. Instead of autoregressive prediction, DiffusionGemma uses an encoder-decoder setup where a noisy token sequence gets refined iteratively. The result, 256 tokens emerge simultaneously. The specs are relevant for builders. It's a 26 billion mixture of experts model. Only 3.8 billion parameters activate at inference. That's the effective compute cost. It fits in 18 gigabytes of VRAM. That's a single high-end consumer GPU. Gemma 4 Foundation, built, trained, and released by Google. Code and weights available now. Why this signal matters right now. Token by token generation is the inference bottleneck in production systems. Latency kills user experience. Parallel generation approaches have existed in research for years. Diffusion models, non-autoregressive decoding, speculative sampling, but those stayed in papers or closed systems. DiffusionGemma is the first open-weight model putting parallel generation into the hands of builders at scale. What we don't know yet, and this is critical, latency numbers versus baseline autoregressive Gemma, quality consistency when generating 256 tokens at once versus sequential refinement, whether the parallel approach holds up on reasoning tasks, code, or just works well for content generation. Real deployment numbers from production systems using it. This is unconfirmed reporting, which means Google's claims about parallel throughput need independent validation. But the release itself is verified. The model weights are public. Builders can test it today. The broader context, open source inference is accelerating. Gemma keeps improving. The research community keeps pushing alternative generation methods into production. If DiffusionGemma's latency claims hold, this becomes a viable alternative for teams optimizing for speed over sequential depth. That changes the inference hardware and software stacks you'd choose. What to watch, real-world latency benchmarks from production deployments, token quality metrics on long-form generation, whether other labs ship parallel generation models in response. If the research community forks and improves DiffusionGemma faster than closed models evolve. If you want to stay ahead of moves like this, I build these systems for a living. Join the community. Link in the description. Build the system, automate the rest.